another day. Let's get a few moments going. Just test and see everything's working, and I do want to get into the questions. It's going to be interesting. Yeah, it's not much to say. Let's see. What does it sound like? Sound okay? Hello, hello. I do want to get into the questions. That sounds so much better. Okay. All right. Let's do it, man. Let's do it. So let's go for this question. Let's just make sure I can see it. Yeah, it's fine. Okay, cool. All right. So put on a different setting so I can more easily find questions. All right. Let's see. How does this go? How do we do here? I think my computer's running slow. I might want to actually restart the computer. Think about it. It might be manageable. Let me read the question. I'm gonna change something. Count number of distinct integers after reverse operations. Given an array of nums consisting of positive integers. You have to take each integer in the array, reverse its digits, and add it to the end of the array. You should apply this operation to the original integers and nums. Turn the number of distinct integers in the final array. Huh. So we're going to take every integer in the array and reverse its digits. And then, you could transform the array and then transform unique. If you just distinct the integers themselves, the only ones that are relevant, that it might be an issue, would be the ones that have leading zeros or trailing zeros, right? Because if you reverse them, then I have to include the reverse. Oh, you include the reverse in addition to the other ones. Oh, okay. I guess I do have to reverse them all too. Okay. The number of distinct integers. Interesting. Also, what is 10 reversed? Is it 1? It is. Okay. Oh, this is an interesting question, huh? How many elements are there? 10 to the 5th, 10 to the 6th. Okay, I was thinking I could use a frequency map. Might be easier. The problem with using a frequency map here is that it's going to have to be kind of large. Yeah, a billion numbers is too big. Easiest thing to do here is just like literally perform this operation and then use I think sort unique and then find the size of the array afterwards. Sort unique erase. Unique erase, I think unique erase does unique erase. And see that the elements be sorted. I think doing this like very directly is probably the way to go. What's up? What's up, Yash? Hey, how's it going? 4 a.m. in my country. So into coding, I didn't notice the time. Anyways, hope you're doing well. Fall into slumber. Yeah, very good, man. Yeah. What's up? I appreciate you coming by, saying hello. Yeah, you should probably get some sleep, man. Sleep's super important. Super important. Only removes consecutive duplicates. Okay. All the duplicates. Got it. So I think I am gonna do this, I think, in a very straightforward way then. It's probably the best way. Let me go ahead and let me give me one moment. One moment. I think this approach is just going to be. Okay. Yeah, this one is just going to be basically do what they say. Dump all the elements into the vector from left to right with the digits reversed, and um, yeah, excuse me, with the digits reversed, and then you sort them, and then unique, yeah, sort and unique at the end, and then count the size. So we're going to say reserve size shift left 1, return size, say constant reverse digits, constant x, and say int result 0. Actually, we're not gonna make this const x greater than 0. Result times equals 10. No. Yes. Plus equals x mod 10. And then x divided equals 10. So the way this works is the least significant digit becomes the most significant digit. Yeah, this goes right to left. Yeah. It'll basically swap the order of the digits. The least significant digit becomes the most. Yeah, this is correct. All right, reverse digits. Instead, transform. It's gonna be nums dot begin, nums dot end. It's gonna be nums dot end minus 1, basically. And we're gonna do reverse digits. Something like this. I have to double check the exact syntax. And then stood sort in, end. And then stood unique. Stood erase. Something like this. Okay. This is output iterator. Beginning. I want the transformed elements to be appended into the. I think it's I think I have to do it a little bit differently than this. I think I need a pushback iterator or something like that. Stood back inserter. Okay. Yeah, should back inserter. Okay. I was gonna say I think I need to do something a little bit different. No. Sort, erase. Okay. I think this works. Oh. Hmm. Okay. It's nums.erase. Oh, nums.erase is probably what I need. Is that because it's C++, not C++20? That might be why. Just a distance, interesting. Oh, and I could use just a distance. I should use that. It's the distance between, I think it's last, first, and unique. And I guess num stuff. Slightly more efficient, unnecessary write operation. Hmm. Static cast int. Should probably use static. Oh, it's correct now. Okay. Does not accept iterators. Oh. Okay. Let's see. Hello, what's up, Alan? How's it going? Welcome. Howdy, howdy. Hello, hello, hello. Hello, hello, hello. Using a compiler flag older than C++20, or you're just using C++20 syntax. Containers erase. Works in all of these. Okay. Correct syntax. Container and a value, not iterators. Oh. Oh, okay. I guess it's supposed to be nums.erase. Okay. I guess it's fine. A little bit counterintuitive to me and kind of not how I remember it, but that's fine too, I suppose. Let's see if it's correct. It's right. Okay. It's pretty fast. It's not the fastest, but it's relatively fast. Okay, now let's do distance. Let's see how that goes. Okay, it's reasonably fast. All right. Okay, let's see. Let's see if we can get 100%. What might be some improvements here? Like to get 100% speed. Oh, okay. That part's not a question. So let's see. So okay, we get that's pretty quick, but I should be able to get 100%. This is reasonably fast. Sort unique to hash set approach. It's cache friendly. Comes a bottleneck. Use a hash set. Okay. Okay. An ordered set. Do not modify nums. Fast IO. Inline. V lambda static. Should I use the hash set? Static. Full array. And some other ideas. I don't think the hash set's faster. Could try a hash set. Um, okay. Could do it this way. Excuse me. Oops. We also do the fast IO as well. Um, um, stood sync with IO false. something like that. And instead, instead cm.tie. Okay. Let's try this. Let's try this one. Okay. Oh, do I not? I'm sorry. I think I forgot to put the camera back on. My apologies. It's gonna check it. I think it's. Did I not? Not the iOS to sequence.io. Okay. Oh, it should be an ordered set, not a map. Okay, let's go for it. Is it correct? Is it any better? This is a lot slower. My first solution was quite a bit slower and faster. Um, mhm. Okay. Ordered set. Static bool is significantly faster. Will likely get you to 100%. Spot on overhead. Dynamic memory allocations. Hash function calculations and pointer chasing, which causes cache misses. Bool array efficiency. Only a megabyte. Fits easily in the L2L3. Accesses direct indexing, zero hashing, zero allocation, optimal solution bit setter, static bool array. Okay, bit set most efficient, cleanest. Optimized for space. It's extremely fast set and test operations. Bit set. Okay. Okay. Static global bool array, fast as possible. Raw bool char array works. Raw array inside the function static. Stack, safe for use vector char, static array. Char scene. Rest digits. Okay. Sorting and hash sets. Is the cache performance very quick for sorting unique? That's what I was concerned about. Perfect index. Tiny space overhead, low in place, tiny allocations. Linear average first. Stem bit set bool array. Range of values small unknown. Direct indexing, memory layout. No allocation. Okay. Okay. So should it be a array of bools, array that's I think a vector is naturally converted. That's that on going to make this. Okay. What does it think? Oh, I missed all this extra stuff here. Hmm. Okay. Let's go with array of bools. Okay. Scene is fine, I think. Bool array of 1,000,001. Right, and this is going to be false. Just digits, and we're going to say scene XOR equals true. And then, yeah, and then scene of first digits. It's also true. Oh, I did this wrong. So result. Oh, we want the distinct ones. So if it's not distinct, then it's not seen. Okay. Hmm. Ooh. Seen once, seen twice. About this. I don't know if this is any better. I could try this. Okay. Um, oh, hold on. Okay. So plus equals seen of x and not seen twice. And the same thing with RD. And then both all of these are set to false. Okay. Something like this. What are we doing here? Error. Oh, okay. So it's healthy. All right. So this is a little bit different. Did I run this one yet? Interesting hybrid. This is interesting. I'm not sure about this one though. Let's do this here. Oh, right. That's true. That's my mistake. That's kind of a curiosity, but it's also my mistake. I maybe should just do. Okay. Just put on 2 lines to keep it simple. Let me see if this compiles. First compiles and runs. Seen twice, seen once. Oh yeah, that also matters. Refactory. Oh gosh. Okay. Okay. Wrong. Okay. Got 3, expected 6. Interesting. So his logic is wrong. My thinking was that I would, if I see it twice, then that's, oh, it should really or equals, I think. Yeah, that might be wrong. It's going to be seen twice, and we set whether or not we've seen it once before. And then we set once before right after. And so we only see it twice if we've seen it once before. So the first time this will be false, then this will be true. Second time this will be true. And then when it's seen again, it'll just be true again. So it'll be idempotent after that. So I think that's correct. Get the reverse digits, do the same thing. And then we get the result. It's distinct if we've seen it once and we haven't seen it twice. And we do the same thing for the reversed version, reverse digits. We've seen it once, we haven't seen it twice. And then we set everything to false. And did I get too many or didn't get enough? It said. Okay, looks like so actually this should come before. There's a possibility of running into issues if I don't do it this way. Because if x and this reverse digit are the same, then I'll end up double counting that one. Still, there's something odd here. What let's look at the example and see what I should be getting. Yeah, my logic might have an error in there. So 10 is unique. And I think that's the only one, and 21 is unique. Example 1. Oh, excuse me. I'm sorry, I did this wrong. I see. That's a mistake. No. It's just it's not integers that have only been seen once. It's just integers that have been seen at all. Okay. Got it. I don't know why my mind went off into that world. It just has to be seen. It doesn't have to be seen once or twice, just seen at all. Okay, so I had the right idea initially, though. I could just use RD. Okay. And then I can just add. Yeah, I kind of get that a bit confused. Okay, let's try this. A little bit confusing. Compiler. D. There we go. That one's much better. Much better. Much, much better. There we go. This is probably 100%, I think. Let's try this one again. What do I want to say here? I did want to check something. It's, yeah, you're gonna have a little bit of what do you call it? I'm gonna have a little bit of buffering here. Okay. I'm gonna keep trying until I get 100%. Keep rolling. Logical flaw. It's getting confused about the logic. Okay. Optimizations. Okay. Char. Optimized. Vector rule. Okay. Static char maybe. Mhm. Okay, it's pretty fast, but it's not 100%. It's close. It's not 100%. Char. Char may be faster. Don't need to just take a look again. Yeah, it's fast, but it's not perfect. Okay. Oh, wow. Memset is safer and faster. Interesting. Memset does fill optimize to Memset. So this is still pretty fast. Um, um, yeah. Let's try this. Mm-hmm. Hmm. Oh, wow. So just do memset, okay. Interesting. So I should use memset more. Um, hmm. Okay, this is pretty fast. It's not the fastest, but it's pretty fast. Okay. It's really close. It's really close. Not the fastest. Okay. Hmm. Top tier solution. Optimal solution. Okay. Dang, it's not quite the fastest though. It's really close. Hmm. Uh, just a little too slow here. Oh, got it. 100%. Got there. We got there. 3 milliseconds beats 100%. Got there. BEA, beautiful. All right, let's go to the next one. It's pretty good. It's pretty good. Lexicographically smallest palindrome. Given a string S consisting of lowercase English letters, and you're allowed to perform operations on it. In one operation, you can replace a character in S with another lowercase English letter. Your task is to make S a palindrome with the minimum number of operations possible. If there are multiple palindromes that can be made using the minimum number of operations, make them lexicographically smallest. String A is lexicographically smaller than string B of the same length. From the first position, they may differ. String A's letter that appears earlier in the alphabet than the corresponding letter in B. Turn the resulting palindrome string. Minimum number of operations to make a palindrome is 1, and the smallest string. Okay. Change G to F. Okay, I have to make the whole thing a palindrome though, right? Okay. So I think the way to go is from left, basically left to right. You're going to compare characters or left and right simultaneously coming in words. And I think the thing to do there is to see when they're different. That's one difference that needs to be made. In order to get the lexicographically smallest of the two characters to select, I would select the smaller character of the two. This should be linear time, and it should be pretty straightforward. This one I think is pretty straightforward. So we're going to modify S. Okay. CH1 and CH2. Okay. If CH1 is not equal to CH2, and quite frankly, we don't even need to. We're gonna return this anyway, so we don't even need to count. Just gonna say some CH2. Then we're gonna set CH2 equals CH1. And the other way around. I think it's something like this. See how we're doing in terms of string length. Okay, seems okay. Let's see if this is right. Runtime error, okay. Really? I think I get that wrong frequently. Let's try this one. I don't think I need to touch the middle one, actually. Yeah, it should be it. Let's go for it. Let's go for it. I didn't really think too hard about whether this is correct. I think it's right. Okay, there we go. Should be the optimal solution now. This should be the fastest. Why isn't this the fastest? Should be really fast. Huh. I don't know. I don't know how to go faster than that. Point arithmetic overhead, branch prediction, and redundant calculations. Okay. 2 pointers instead of. Okay. Um. Stood min. Okay, so stdmin's faster. Didn't really help much. Huh. Optimal. When arithmetic is not a bottleneck. Achieves 100%. Okay. Yeah, you're right. Okay. Pretty good. Write code that enhances all arrays such that you can call the array.groupByFn method. Oh, this is JavaScript. Okay. Grouped version of the array. Grouped array is an object where each key is the output of fn array by, and each value is an array containing all items in the original array, which generate that key. The provided callback will accept an item in the array and return a string key. The order of each value list should be the order the items appear in the array, and the order of keys is acceptable. Solve it without Lodash group function. Okay, so ID1, ID1, ID2, function item.id, output 1, ID1, ID1, 2, ID2. Output is from array.groupBy function. The selector selection gets the ID out of each item in the array. There are two objects with an ID of 1. Both those objects were in the first array. Okay. Array 1, 2, 3, 1, 3, 5, 1, 5, 9. Sort by the first element. Stick them all in here. Okay. Excuse me. String of n greater than 5. So it's either true or false. The question here is it sorted? Okay, that's interesting. Sure. So, f of n to group by array prototype. Okay. I'm a lot less familiar with JavaScript. How do I access the array function? Let's call that. Okay. Hey, what's wrong? What's up, programmers? B5K. Howdy. This problem is 2631 group by. The previous problem was oh, it's gone now. I have my list. It removes it's filtered by things I've already solved. But the previous one was I actually don't remember what it was now. My mind is fully context switched. What did we do? We tried to optimize. I don't even remember. I have to look. I literally have to look up what I just did. Brain is completely switched to the next question. Oh, right. That one was a palindrome. So you've got a string, and you've got to turn it into a palindrome, but you've got to get the lexicographically smallest palindrome, and it's got to be the minimum number of modifications to make it a palindrome. Okay. Access the array. The method was called on using the this keyword. Oh, okay. No. Oh. Show me this. Okay, then this keyword. All right. So we're going to return. What are we returning? An object. How do I create an object? And how do I create basic objects in JavaScript? I think it's just like OBJ or something. All right, we're going to do like results. I think it's something like this. I don't remember. I don't use JavaScript that much, or at least not recently. So we're gonna say for like item. I don't remember this either. This. But oh, I do. Okay. If yeah, it's let. That's the right one. Yeah. Iterating over the objects in this array. Don't remember exactly how to do this. Something like for item in this. We're gonna do a result of like function of item. If I create, how do I create a property or a key? Create property. Oh, I remember now. There we go. Push item, something like this. I don't know exactly. Avoid for in. All enumerable properties can cause bugs. Traditional for loop. Const item of. Cleanest. Most common. This for each. This for each. Okay. For each for of. Traditional for loop. Excuse me. For in, probably not. Two critical bugs. Iterates over properties. So I'm in this. All right. So let's do for of. It should be const item of. And then item is the index. Okay. Push on undefined. Okay. Initialize the array for each key before pushing. Const key. Get the actual value. Group key. Initialize that it doesn't exist. For each. Okay. Does the of also only pick the index? Would I be able to? Over the items directly. So I could. Okay, so the main issue is that's our const index, or we already have the index. The key is going to be fn of. It's not even const object or item syntax. And then key is going to be the fn of the item. And then the values, not the indices. Oh, okay, 4 of, so I want that. Okay. Is there a push? Automatically generates the array, doesn't exist. So if not, okay, so this is basically it. No. Must manually check. The nullish coalescing assignment operator. Okay. What in the world is this? What? Oh my gosh. Excuse me? The nullish coalescing assignment operator. Gosh, man. That's crazy. Brother. I like how it answers it completely honestly. I was just joking. I'm joking. I'm joking. Like that. Coalescing nullish assignment operator. Something straight out of the void. All right. So it works. When I'm using JavaScript, I don't really try to get like the absolute fastest. I just try to get it to work. I'm doing LeetCode problems. What is it? It was double question mark equals. It's crazy, man. It's crazy. It's crazy, man. This is crazy, man. Simplifies my solution though, for sure. Definitely feels like magic. I didn't mean in a good way. I mean, it's like very confusing and probably obscure syntax. Doesn't even work well. Well, there isn't that isn't particularly cross-compatible, particularly backwards compatible. Not confusing, but foreign. Foreign. Very foreign. What's up, chat? Hello, 5 a.m. Hello to you. Howdy. Say it's India. Hello. What's a LeetCode? What's a LeetCode? That's a good question. You're absolutely right, dude. I love how the oh my god, dude. Oh yeah, it's so much fun. It doesn't even specify what it agrees with me on. It's just like absolutely right. Everything you just said, perfect. Uh I'm being kind of facetious. This isn't. I'm not trying to be mean to anybody with this. It's one of those things where you're like, wow, it's a weird syntax. Oh my gosh, dude. Oh, this is too funny. All right. So LeetCode. For those of you wondering what LeetCode is, For people who want to be software developers, the large tech companies kind of dominate the market for jobs, and they also have adopted a way of testing people. There's too many applicants most of the time, like there's too many people applying. So they need to find ways to reject people. And one of the ways they reject people is they force them to solve these LeetCode problems. So this is a LeetCode or a LeetCode problem. It's basically a technical interview question for software developers. And it's kind of like usually like basically like an obscure puzzle that you solve with an algorithm of a program. All of a sudden, the runtime is so much lower now. Before it was like 90%. Now it's so much lower. Um, and yeah, that's what this is. That's what I'm doing. I'm working through these puzzle kind of program things, sort of logical puzzles that you solve with the program. Kind of like that syntax though, even though it's pretty like. Oh wait, hold on. I think I go the other way. There we go. Yeah, I think this is the one that I had before. It's not backwards compatible and could be considered obscure. Yeah, it's fucking kidding me. It will crash. Okay. Although it's probably supported in most browsers, but it's pretty funny. Yeah, readability. So browsers a little bit different than like it's important to have backwards compatibility for various reasons, but browsers are. I'm actually not sure about browsers, how much more important it is. I think, I don't know. Actually, I don't know. I think most people have modern browsers, typically, something like that. Okay, so my code is, I mean, this is probably about as good as it's going to get for this group by. It's probably about it. Okay. Okay. What? Nah, I'm not going to bother. I was going to say, like, let's try to figure out the optimal solution, but that's probably fine as it is. Okay. Hi. I like this. This is kind of fun. Um, all right. Rings and rods. There are n rings, and each ring is either red, green, or blue. The rings are distributed across 10 rods, labeled from 0 to 9. You're given a string rings of length 2n that describes the n rings that are placed onto the rods. Every two characters in rings forms a color position pair that is used to describe each ring, where the first character of the ith pair denotes the ith ring's color. The second character of the ith pair denotes the rod that the ith ring is placed on, 0 through 9. For example, R3G2B1 describes n equals 3 rings, red ring placed onto the third rod, green ring, the second rod, blue ring, the first rod. Turn the number of rods that have all three colors of rings on them. Okay. So this one's pretty straightforward. Kind of just do some processing here. And yeah, it's probably the easiest thing is to use bit array. So we'll try to optimize a little bit here. Do some optimizations. Let's go with this one. Let's do static red, static bool, red 101, green 101, and blue 101. And each of these, we're gonna say, I think they were saying char is better than bool. So we'll do that. Actually, we're just gonna use bool. It's fine. We'll just keep it simple. Probably don't need to put this on 2 lines, but I'm going to. All right. So we'll just do memset at the end. Each of these, red 101. Oh, red, false. Size of red. The same thing. Oops. For each one, red, green, blue. I think these are all the same size. but that's okay. All right, result. And we just go ahead and say string rings, each ring for I is 0, I is less than the range that size, and I, next one, I'm going to say red. First we're going to do const char color is range of I, const char wait a second. Oh, and rings. Oh, I did this wrong. Oh, wait a second. Oh, so there could be a lot of rings. Oh. Oh. So I'm actually wrong here. These don't need to be so large. Sure. Okay. Yeah, okay. It's fine. Target. And this can actually just be subtracting. Just you could even do index. Okay. So red of target index or equals color is R. And green, blue, green, and blue, G, B, and we say just a quick I 0, I is less than 9, but I is 10 really. This equals green, red, and blue. I think that's it. Something like this. What's going on, chat? What's up, chat? I think oh, okay. Oh, there. Oh, it's supposed to have a comma. Okay. Runtime error. All right. Out of bounds. Okay. First character is the color. Second character is that's okay. Let me let's pull this off. Okay. This is probably correct. What I go for. Is this the fastest solution? I don't know. Might be. I guess we'll find out. It's correct. And it's the fastest. Yeah, it's fine. This is not such a hard question. Basically, you just keep track of Boolean values for each rod, if there's a red or blue or green ring there. And then just process all the string left to right and basically add rings as you go. And by adding rings, we just check red, green, blue and update the associated Boolean. And then at the end, we can just add all the rods that have. There aren't that many rods to look through, so you just add them all right here. It's pretty straightforward. That's a pretty easy one. It's definitely one of the easier ones for sure. Okay. Let's keep going here. LeetCode hard. Here we go. Okay. Maximum score words formed by letters. Given a list of words, list of single letters, might be repeating, and score of every character. Return the maximum score of any valid set of words formed by using the given letters. Words of I cannot be used 2 or more times. It is not necessary to use all characters and letters, and each letter can only be used once. Score of letters A, B, C is given by score of 25 respectively. Okay. So we have words, we have letters, and a score for every character. Maximum score of any valid set of words formed by using the given letters. Words of I cannot be used 2 or more times. Okay. Can only use the words at most twice. I'm going to create a set of words. And we're going to use the given letters. Okay, so words, dog, cat, dad, good, letters, A, C, D, 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 G, O, score for the letters. Okay. And we get 23. Score A is 1, C is 9, D is 5, G is 3, O is 2. Given letters, we can form the words dad, good, dad and dog only get the score of 23 or 21. Dad, good. Interesting. Oh, here's an interesting question. I can see why they put it as hard. I guess I can see why. All right. There's 14 words to work with. The words themselves are at most 15 letters. The letters to work with are only about 100. Letters.I.length is 1. Score length is 26. Scores between 0 and 10. Contains words of I, letters of I, contain only lowercase letters. Okay. Interesting question. So I don't know immediately the answer to this one. This is one of those questions that I do not actually know the answer to immediately. I have to think about it for a little bit. So, and I can only use each letter once, or yeah, I can only use the letters number of. I could make a frequency map out of the letters. That might be easier than using them in this form. I could also evaluate the words and get a score for each word. And then the idea would be, okay, try to I can only create 2 words each way. I can only create 2 words. Oh, excuse me. Cannot be used 2 or more times. Oh, can only be used once. The words of I can only be used once. Okay. Oh, interesting. I mean, a greedy approach is probably fine here. I just try to get the most expensive. No, it's maybe not the best. I could try to do every subset of the words, which is there's only 2 to the 14th of those, which is not that many. I could try that. I could try looping through every subset of the words. And quite frankly, actually, just using the letters themselves as much as possible is probably like one of the easier ways to get. I'm trying to think of like the fastest way to do this. Well, let's just think of a way. So one way of doing it would be every group, or excuse me, every subset of the words, and I could check if I have enough letters for those subsets. If my frequency map of letters matches the frequency map for that subset. If it does, then I can get that solution, and I use that as one of the maximum scores. If it can't, then I don't, and then I just get the maximum scores that way, and then take the largest, and that's that. It'll be if the letters are only actually there's only the frequency map is only going to be 26 at most 26. So it's just comparing the two frequency maps. And then I can just obviously multiply the frequency maps that I get by the score. So it's constant, it's 26 times like 2 to the 14th, which is 2 to the 10th is roughly 1,000, and then 2 to the 4th is 16. So it's about 16,000 times 26, which is, it's on the slower side, but it's pretty fast overall. That's probably actually fine. I might get actually 100% on this with that score, with that approach anyway. So I can do let's do int frequency of 26. And this could be empty. This also could be static. I don't need to keep reallocating memory for this. Static, and then int current frequency. Just the vim set. We're going to say for const char ch letters frequency of ch minus a. Then we can say for each we can use could do it this way, int bit or subset. This way, subset 1. Subset is less than bit shifted by words that size. Increment subset. And we say 4 bit equals 1. Bit shift equals 1. I equals 0. Less than 32. Plus I. I think it works like this. I actually think this could just be words that size also, by the way. And then we would say, so we could build the current frequency. So for each subset, we have stood set current frequency 0 size frequency. Then we're going to say current for if bit and subset. And we're going to say const char ch and words Increment current frequency by CH, say. Okay. Subset memset. Each bit. Okay. And then we're going to say for J, right high. It's less than 26. And I will check it's true. Not check. Check, not check. Check equals check and equals. It's going to be current frequency of I is less than or equal to frequency. So check is true. Then we're going to actually I could just have a result. Just always compute this. Terminate early. Current frequency of I times score of I. Yeah. Check. Then turn value. I don't know what else to call this. I've already gotten a bunch of other possible names I could have used. Turn value equals the x of turn value and result. Yeah, reusing these names here. How's chat doing here? Okay. Okay. All right. So compiler. What? I thought that was a thing. I guess not. Oh, okay. All right, let's try this now. I'm gonna go for it. See how I do. Okay, it's correct. All right, it's on the faster side. It's not the fastest, 7 milliseconds. It's okay, I guess. I'm gonna say result. We're gonna say like score, current score. It's probably better. This is probably better result. It's down here. Slightly better naming approaches. Let's see if with refactoring works correctly. So it's a reasonably fast solution. It's not the fastest. It's okay. That was a LeetCode hard. All right. All right. Let's see what the AI thinks about this. See if I can get this to be the fastest. Yeah. Let's see. Let's see. Likely gets TLE. It's inefficient problems constraints. Okay. Can be too high. Backtrack with pruning. This constraint, in this case, constraints are small. Hmm. Hmm. Mm-hmm. Free compute the word frequencies. Huh. That's not the fastest. Probably could be the fastest though. Sure. Pre-computing word frequencies. Be about 50. Guess. Add. Method. Yeah, I'm not sure. Okay, let's try it. Let's do word frequency. So the word frequency is going to be 15 words, and each of them has 26. Does this applies to double indexed array, double two-dimensional array with zeros across. I think it does, but I'm not sure. It's not as fast as it could be. So this one was a LeetCode hard, which is pretty good. Okay, it does. All right, we'll use word frequency, and then we'll say for inst string as in words. It's chars. Actually, it should be I need to use an index here, I think. We're going to say word frequency of I. of CH minus A okay. Set word frequency by 0 size of I think it's just 26. Well, it's 26 times, I think, the integer size, something like that. And so here we can just do for int j equals 0, j is 26. Increment j of current frequency of excuse me, plus equals word frequency of j. Yeah. All right, how about this one? Pre-computing those values. I'm not sure if that actually helps. Compiler, okay. Compiler is definitely not the most helpful. Or, well, it's helpful, but it's not what I want. Let's go for it. See if it's still correct. Okay, it's still correct, but speed isn't much faster. It's not much faster. All right. Pre-computing adds a one-time overhead, but saves work per subset, which is beneficial. Net effect is positive. Weighs the same computation cost. Right, but doesn't having the extra memory through that more things into the cache. This is actually running a little bit slower than the other solution. No, it's about the same. Doesn't hurt cache performance. Okay. Okay. It's about as good as I got so far. It's consistently about 11 milliseconds, which is not really the best. Oh, that's a good idea. Word score. Didn't think about that. Okay. It's a good idea. Let's try a word score. Mm-hmm. Huh. Well, okay. Let's try this. Let's see how this goes. We'll do it on time. Oh, it works. Got another hour and 20 minutes. Okay. And what is that called? I got get some frames dropping here. I wonder a few things. Yeah, I wonder there's a few things. So one issue. Okay, this works. So this works. So this is maybe better. I'm using some pre-computation to reduce a little bit of the computing. There are a few things to say here. I have another hour and 20 minutes or so. And then also, this is not that fast. There's another issue here. It seems to be getting slower. Wondering if my voice is too loud. I added some gain so that way I could whisper and it'll be louder. I think it's okay. I'm not certain. This appears to be if it's maybe early prunes. Oh yeah, that's a good point. Early pruning is a good call. Okay. Mhm. Valid is actually better. Valid selection, we'll say valid selection. Or valid subset, maybe it's better. Okay. And we don't need this check at the end. We can say, and could say if current frequency of J is well, how, hold on. Let me do this. I see. Okay, got it. I didn't think about that. I didn't think that all the way through. So yeah, that makes sense. So just add this extra break here. The logic they gave me is wrong. The basic idea is right, but the logic is wrong. I would say if current frequency of J is greater than frequency of J, then valid subset is false. With break. I don't need to do this check. I think this is true. I think this works. Yeah, let's try it. Oh, okay. I was gonna say, I was like, oh, 0 milliseconds. That's beautiful. No, it's fast. It's not that fast. Okay. Hmm. So I wonder if I should sort the words first. Total letter cost. Hmm. 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 Okay. Maybe. So this is not the fastest, probably because I need to do some pruning, more aggressive pruning. Excuse me. It's reasonably fast, but it's not the fastest. Hmm. Well, um, hmm. Oh, 5 milliseconds. It's pretty good. Okay, reasoning is correct. All right. Okay, it can work. Oh, okay. Sum of letter frequencies is just the length. Hmm. Okay. Yeah, 5 milliseconds is pretty okay. But I think we can do better. Um, Okay, so I think to sort the words first, before I do anything else. So, excuse me, this bit set, yeah, the first word should be the largest. Excuse me, so to the, yeah, I think this is fine. How's the stream health? It's healthy. Okay. Stream is healthy. All right. Got another hour. Keep going for another hour here. That's correct. Okay. Still 8 milliseconds. Not the fastest. Dang. I was hoping to try to get something a little bit faster. Dang. Okay. All right. Let's look at the other solutions to see. There are quite a few that used to get 0 milliseconds. What do they do? Oh, they use DP. Oh, interesting. Huh. Oh, that's interesting. So I didn't see the DP solution. I went for just a straight bit mask solution and tried to optimize as best I could. Uh-oh. Let's see what this says. Pretty sure it's DP. Hmm. 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 I might need to start another conversation. I don't know if that's true, man. What it just suggested there. No, even the very close, the very small millisecond runs, they are actually sometimes they don't always break into the lower speeds. Like you can kind of tell some algorithms are genuinely a little bit better. I'm not sure what to do here. I'm tempted to try the backtracking solution. Well, let me try one of these solutions. It's faster. Let's try it. Is there another one? Whoa. Oh. Easy, hard. It's a few days ago. Simple backtrack. How about this one? Oops. Huh. It's a trick. Add exit to write 0 to runtime file before main starts. Oh my gosh. That's brutal. That's crazy. Is this really... Let me try something here. Oh, it's faster. No. Basic backtracking is faster. Oh. Dang, man. My code. My code. The code's not as fast as the really simple backtracking solution. It's rough. That's a rough one. Okay. All right. Well, let's go to... Yeah, it's probably the best. Yeah. It's almost certainly burning. Okay. Into backtrack approach. I don't really like doing backtracking as much if I can avoid it. But let's write our own backtracking solution. It's not that hard to do, I think. So we'll do const auto. I'm going to say best store. Oops. Int best 0. Yeah, quite frankly, we'll just capture everything in this. Why not? Third best. We're going to say first. Let's do just like auto this, something like that. Self, I think. This. So I think we just start with we could do a frequency map with the letters, and then process words one by one. I mean, we could also pre-compute the words, but I don't know if I really need to do that. So let's do 4. So it's frequency 6 0. 4. Let's try CH in letters. This also could be static too. Still num set. I'm not sure if I need to do this, but not. Okay, what we're going to do is int index. I'm going to say so we either skip the word or we take the word, right? That's going to be so best equals student max of best and constant take word. Excuse me. We don't even need this, do we? We don't. Okay. Taking the word, we're going to recurse and dropping the word, we're going to recurse in a different direction. So taking the word, do index +1, and dropping the word is also index +1. Our next so start with No, I did this wrong, actually. Okay. So we have take the word case and drop the word case. What we're going to do if we take the word is we're going to say start with 0. We're going to say for constant. I could pre-compute this part, but I'm not going to. This is words by index. We're going to use current frequency. Probably should actually pre-compute this. For now, I'm not going to. Then we're going to say for int I 0 is less than 26. So valid equals true. Valid and valid current frequency of I is less than frequency. Okay. If valid, and update the state. We're going to recurse. And then we're going to, after the recursion, we're going to bring the state back. Okay. Take word is going to be equal to this recursion. And the state's going to be in frequency. We're going to say self of index plus 1. The next one. That's if it's valid. Right, that's what we update the take word to. Otherwise, don't take word is just going to be drop word is just self index plus 1. Oh, I need to calculate the score too. Right. Score is also could be pre-computed, but we're not going to do that. We're just going to say calculate the score here. This works, I suppose. Could try it. Curse 0. Self. Is it like auto this or something? I don't remember how this works. Runtimer. Okay. Oh, if index is greater than or equal to words.size, and return 0. Forgot about that. That's, you gotta have a terminating condition here. Wrong answer. Okay. Yeah, 22 should be 23. Okay, I wasn't expecting it to be wrong. That's interesting. Wasn't expecting that. Okay. Let's try. Oh yeah, so those of you who are curious, this is the problem description. I solved it, but the solution maybe could be better. So I'm trying to do that. It's the wrong answer. Yeah, if I drop the word, then I don't modify the state at all, and I just keep going. It's valid, then I call the recursion, change the state, call the recursion, and restore the state. I get the current frequency and the word score. That's a problem. Okay, I see the issue here. That's subtle. Okay, I can't do it like this. That's why. That's a subtle bug. That has to do with trying to optimize this. This cannot be a static variable in that way. Yeah, I can't use it the way that I was looking to use it before. Yeah, the reason is that it needs to persist beyond the recursive call, which if I try to make it a static variable and mem set it, it's not going to persist across this call in order to restore the state properly. Let's try it, see if it works in all cases. Okay, it's correct. But is it? Oh, fastest solution, no problem. Jeez, man. My gosh, dude. Just a basic backtracking solution ended up being so fast. I don't know, man. Let's try again. That's crazy. That's crazy. Man. I did two solutions. I did the iterative solution and I did the backtracking solution. Prunes. Oh my gosh. Uh-huh. Excuse me. Huh. So that can be improved. While I appreciate your improvements, for some reason this code already reaches 0 milliseconds. Pretty consistently too, I think. I think I did it 2 times already. It was already 0 milliseconds. Yeah, 3 times. 3 times in a row. I need to update the I need to do a new conversations. Starting the context is starting to get wonky. Alright. How are we doing on time? I think it's been another half an hour here. Huh. Okay, that's I think I need to do a new conversation. It's taking too long. Alright, that's pretty amazing. So yeah, just a really straightforward backtracking solution is fine. I don't know what else to say here. Doesn't always get 0 milliseconds, but often does. This is taking a while. Alright, I'm going to try one more time to get the feedback, and then we move to the next question. Let's go to the next question. Yeah, that's pretty amazing. I don't know what to say. Let's say, would you kindly... Yeah, it tends to get really hung up on internet searches. So for whatever reason, adds too much context. Given 2 0-indexed arrays, nums1 and nums2, return a list answer of size 2, where answer 0 is all of distinct integers in nums1 which are not present in nums2, and answer 1 is a list of distinct integers in nums2 that are not present in nums1. Integers in the list may be returned in any order. Excuse me. Okay, great. All right, we're gonna get a new conversation because the previous one was stalling. Okay. Hmm. I didn't solve this before. Huh. Okay. All right, let's do this one. Um, We can swap and pop, actually, might be better. All right, let's try something like this. Swap and pop might be reasonable. Buffering quite a lot. Another half an hour here. Color. Get this wrong. All right, let's try this again. Let's try it again. Wrong answer. Okay. Huh. Oh, we've got, I guess this should be distinct as well. Oh, distinct integers. Okay. Oh. Oh, that's awkward. Hmm. Hmm. All right. Well, fine. Okay. We'll do. This is another way of doing it, I suppose. Wrong answer. Except it's wrong. Ah, it's also gotta be memset. Okay, let's try this. Check the time while we're going here. Yeah, still around 20 minutes to go. Let's see if it's correct. It's probably correct. Okay, it's correct. Fast enough, yeah. All right. I mean, yeah, that's fine. 100% is pretty good. Just go to the next one. This one I think is a JavaScript code. Yeah. Function create counter should accept an initial integer init. Should return an object with three functions. Three functions are increment, increases the current value by 1, and then returns it. Decrement reduces the current value by 1, and then returns it. Sets the current value to init, and then returns it. Okay. Create counter, increment, reset, decrement. Okay. All right. I guess I create an object that has JavaScript objects functions attached. I don't know. Yeah. Methods. Okay. Const person. Traditional function property. Huh. Okay. So function that returns. Is that a class definition? JavaScript's a little weird. I'm definitely not as familiar with JavaScript. Oh wow, there's even more. Whoa. SpongeBob made its way in here. Inside a method, this object. Adding functions. Dot notation or bracket notation. Okay. Dot equals function, adding a method. Okay. Bracket notation, okay. Interesting. Dynamically added methods. Dynamically attach a method. Functions returning objects with methods. Oh. Okay. Oh. Destructory. Wow. Yeah, I think that's kind of what I'm looking for. Interesting. Distinct patterns in JavaScript factory function. Ooh. Fast definition. Okay. Interesting. So there's quite a bit of reading to do there, which I'm not going to do all that. So we're going to have function objects, const increment, and then const decrement, and then const reset. And then we're going to return objects with those stacked functions. Okay. Const, I guess, saved it. And then let current equal init, current plus current, 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 current equal to saved, current. Something like this, I'm not sure. Oh, that looks like it's right. Let's try it. Maybe, yeah, okay. So that was it. All right. I'm not gonna spend too much time on this. This is like JavaScript syntax. Just fine, I guess, to know. So there you go. Okay, I suppose that's fine. All right, we'll go to the next one. How much time do I have? I have another 15 minutes or so. Okay. All right, senior citizens, let's go. Through index array of strings, details, each element of details provides information about a given passenger compressed into a string of length 15. The system is such that the first 10 characters consist of the phone number of passengers. The next character denotes the gender of the person. The following 2 characters are used to indicate the age of the person. The last 2 characters determine the seat allotted to that person. Return the number of passengers who are strictly more than 60 years old. Oh, wow. Excuse me. First 10 is the phone number. The next character is the gender. That's 11. The age is 12 and 13. Okay. I mean, this isn't too hard. Result 0. Const string s details. Return result. This is going to be result plus equals s of, what's it, 12 plus 10 plus 13 and there's an assumption here that this format is always sort of correct, I guess. Wrong answer. Okay. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. It should be 13, 14, 0, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 11, and 12. Okay. Those are the indices for those characters. So, wrong. 207. Oh, excuse me. This is going to be greater than It's greater than 60. Is it greater than or equal to 60? Strictly, okay. Details is between 1 and 100. Oh, digits 0 to 9. Okay. It's great, I suppose, but there's one issue here. What if it's 0, 5, or just 5? One tiny issue. This approach. Invalid test case. Okay, so it has to be 15. Okay, so it's always going to be. I think this works then. I think it works. I could be wrong. That's fine. I think there may have been a way for me to double check, but I didn't really think it through. It's accepted. Okay. Right. Yeah, there's not much to say about that one. That one's pretty straightforward. You just take those two characters, one of them you multiply by 10, and the one you don't, add them together, and then check if it's greater than 60 and that whole thing. If it is a true or false, you add that to the result. All right, next. So how are we doing on time? Yeah, we got 10 more minutes. Okay, getting a little bit. 10 more minutes and getting a little bit. What's the word? Little bit of buffering. Find unique binary string given an array of strings, nums containing n unique binary strings, each blank n. Return a binary string blank n that does not appear in nums. If there are multiple answers, you may return any of them. Array of strings, nums containing n unique binary strings, each n. Array of strings, nums. Okay, array of strings. Unique binary strings, each blank n. Okay, interesting. Okay. Turn a binary string like that does not appear in nums. If there are multiple answers, you can return any of them. Oh, that's cool. That's interesting. Okay. Sure. I mean, you can convert the binary. How long is n? N small. You can convert the binary strings to numbers, and then just get a number that's not in the 2 to the 16th is relatively small. It's like how much is it? 2 to the 6th is 64. Yeah. It's only 64,000 numbers. Excuse me. What's the fastest way to do this? I could sort these and then binary search. Actually, probably the easiest thing to do is sort it, and then it's only 16 strings, right? N is equal to nums dot length. That's super small. So yeah, I could sort it, and then just look for the difference. Like, so if the first string isn't all zeros, Basically, I could just go. Yeah, check if the first string is not zeros. If it's not, then just return that. That's the simplest case. And then every element after that, I would just check if adding 1 gives me the next element or not. And if it doesn't, then I can use that one. Create a binary string out of it. Alternatively, I can just C++ binary strings. I think there's actually a way to do this that's really direct. And I could do it that way. Sure. Let's do it this way. Excuse me. S2I with base 2 or std bit set. Std bit set. Bits 2u long. Okay. S2I is 2. Okay. There are other ways to do this, but using the built-in facilities and faculties here is probably best. Okay. Yeah, so basically, if the current is not equal to the first value in nums, then we can break. If it is equal, then we're going to increment current and I, and we're going to find the first point. Basically, it's going to calculate the max. And then from there, I should be able to turn reverse operation. I think I can use a bit set. Std bit set or std format. Okay. Value 2 string. Yeah. Const Let's see, I think bitset does this. And then, okay. I don't remember how to truncate the string either. I mean, there's a way to do it, but first one, extract the remainder, remove leading zeros. Actually needs to be a specific. Actually needs to be a specific. Removing some. It's correct. It's going to be removing leading zeros, but it actually only needs to be 16, by the way. It doesn't need to be 32. Because n is at most 16. And it says that n, the size and the number of bits are going to be the same, the number of words. Take the last n bits. Substring. Okay. Just substring length minus desired length. Oh. All right. Sure. I don't know about this one. 16 minus, no, it's not size. I don't actually know about this one. There's a few things about this that are questionable. Oh, should be array of I. Forgot that I did that. Okay. Oh, it's 6. Okay. I'm going to go for it. This may or may not be correct. Also, how are we doing on the... Oh, yeah, okay, we're actually over time now. That's correct. Okay. That's pretty straightforward. That one's not too bad. It actually worked. Okay. Substring, I think, gives me starting point, or to the what substring? What's the substring syntax? Actually, not entirely sure why that worked so well. So I think I'm done here. I think we're done for today. If you like the stream, don't forget to follow, like, subscribe, all that stuff. We're not follow, but subscribe. I don't know the syntax, so probably should know the syntax for that. That's pretty straightforward. That wasn't too hard. Position plus count. Oh, the count ends up being, okay. So if I start with a certain position, it'll take everything else. Okay, I got it. So it basically will, if I don't specify the amount, it'll default to everything. So when I take 16 minus the desired amount, it's going to scroll over left to right to that position. So like, let's say it's 5 characters, 16 minus 5 is 11, it's going to get position 11, and then take all 5 characters after that, which would be 11 to 15, 15 minus 11 plus 1 is 5. Okay. Interesting. So that's why that works. I was going to say something like that should be the thing. Should be how that works, the syntax. So it's a position plus a count amount, and then it'll just give you the full count amount if you don't specify. So that's reasonable. All right, it's pretty good. It's pretty good. Pretty straightforward kind of a deal. Yeah, it's a mex routine, simple mex routine. Just convert the strings to integers, calculate a mex value, and then convert that integer back to a string. And that's it. Very straightforward. All right, let me stop here. Thank you all for watching. I do appreciate it. Not much for me to say beyond, as I mentioned, if you like the stream, like and subscribe and all that. Yeah, it was kind of fun, kind of interesting. I guess the thing to do now